bonding modes of CO. So, how the bond formation will take place between carbonyl and metal, we going to see. So, carbonyl as the ligand, it donates electrons to the metal ion and forms the coordinate bond, that is called a sigma bond. Okay. So, metal is with empty d orbitals like this. Okay, so it is with empty d orbitals, acts as Lewis acid as acceptor, which can accept the electrons, right? And where carbonyl is with filled sp hybrid orbitals, so it can donate electrons, so it acts as a Lewis base donor. So carbonyl is giving electrons to the metal ion and forming the coordinate covalent bond like this. Okay, so this bond will be said to be sigma bond, that is coordinate covalent bond between metal and the carbonyl. Okay, so this is the sigma bond formation. So as the carbonyl is giving the electrons to the metal ion and metal ion is taking the electrons, right? So for a time what will happen, the electron accumulation around the metal ion is more. So at that time, metal can donate electrons to the ligand. Metal in a position to donate electrons to the ligand. So what could be the status of the ligand? Ligand should have the vacant pi star orbital, right? So as we now seen in the MOE diagram of CO, it has vacant pi star orbitals, right? So it can accept the electrons. So in pi bond formation, what will happen is metal is with filled metal d orbitals. So metal is having electrons here, right? And carbonyl is with vacant pi star orbitals. So it is in a position to accept electrons from the metal ion. So here the metal is acting as Lewis base, donating of electrons, and ligand is acting as Lewis acid, accepting of electrons, right? So the bond which is formed between metal and the carbonyl is said to be pi bond here. Okay, so metal to carbonyl, the electron passing is metal to carbonyl, and which is calling as a dative pi bond. Okay, this is the pi bond formation. If we see this picture, metal to CO. So CO is donating electrons. This is sigma bond, and metal is donating electrons. This is called pi bond. In sigma bond formation, metal is Lewis acid and carbonyl is Lewis base. In pi bond formation, metal is Lewis base and carbonyl is Lewis acid. And the carbonyl is attached with the metal ion as in terminal positions and in bridged positions. So if it attached to the metal ion in terminal positions, it is called terminal bonds. That means the carbonyl attached with only one metal in terminal positions like this. If the carbonyl is placed in between two metal ions, the carbonyl acting as a bridge between two metal ions, right? So this bond can said as mu2 bridging, carbonyl with two metal ions. If the carbonyl attached with three metal ions, 1, 2, 3, okay, this carbonyl is attached with 3. So this bonding is called as mu3 bridging bond. And the example Fe2CO9. So two iron atoms will be like this, and three terminal carbonyls attached with each iron atom like this, 3 each. Okay, and remaining three carbonyls will attached with the metal ions in bridged position. Each carbonyl is acting as a bridge between the two metal ions. Okay, and the stretching frequency of bridged carbonyls is 1829 cm inverse, and terminal carbonyls is 2082 and 2019 centimeter inverse, and the bond length between iron to iron is 2.446 angstroms.